Great. Let's move towards the second type of reactions, which is known as the endothermic. Okay, let me get some
Mm-hmm.
more space quickly. So the second type of reactions we're going to talk about are the endothermic reactions. Okay. All right. So what happens in the endothermic reactions? These are the exact opposite of exothermic reactions, right? That means in endothermic reactions, what they're going to do, they're going to take in energy, take in, or you can use the word absorb, right? So they take in or they absorb energy from the surroundings, right?
Yeah.
Okay. So there are many examples around us, in which there are many reactions that are actually absorbing energy from the surroundings and then taking place. So in that case, we are going to look at the energy level diagram as well that I showed you for the exothermic reactions as well. So in case of endothermic reactions, if you try to draw the energy level diagram, so you would notice that if I label energy here at the vertical axis showing an increase going in the upward direction, you would see that products would be at a higher energy level as compared to the reactants, right? So
Yeah.
products, they're at a high energy level as compared to the reactants, okay, which are at a lower energy level in that case, right?
Yeah.
Right. So that means we can say that this energy difference is occurring because energy is taken in. So energy is taken in from the surroundings, right? So energy is basically taken in from the surroundings. That's why you can say that in the endothermic reactions,
Yeah.
the products are at a higher energy level. So we can write down this point as well, that the products are at a higher energy level. Okay, so products, they are at a higher energy level in that case, right?
Yeah.
So if we just write a general form for this reaction, we can just write it as reactants, okay, along with, because they're going to take in energy, so they absorb energy and then they give products, right?
Mm-hmm.
So this is more like a general format of such type of reactions in order to understand them. So let me just write a similar thing for the exothermic reactions as well. So for the exothermic reactions, basically it's kind of opposite. So you can say that the reactants would actually be releasing energy while forming the products. So we'll write products plus energy. So this is a generalized idea for the exothermic, right? The same way I wrote it for the endothermic as well down there, right?
Yeah.
Exactly. So you can see that we have this energy level diagram, hence showing that products, they're at a higher energy level as compared to the reactants in the endothermic reactions. So in the endothermic reactions, if you just try to look at a chemical reaction, let's say we take the decomposition of calcium carbonate, which is CaCO3. So calcium carbonate in the solid form, when you break it down, it breaks up into calcium oxide, again in the solid form. And along with that, carbon dioxide gas is released because it's a carbonate. And whenever a carbonate decomposes, carbon dioxide gas is given out, right? So in that reaction, the energy change would be represented with a positive sign. So it's going to be positive 178 kilojoules, right? So it's going to be
Yeah.
positive 178 kilojoules. So this positive sign, like we just saw for exothermic, that it's going to have a negative sign with it, right? So
Yeah.
endothermic would have a positive sign. We can say positive sign for the energy changes, right? So that's exactly how we can identify such reactions, that they would be having a positive sign, right? So now looking at some of the examples of the
Yeah.
you know endothermic reactions from our daily life. First of all, you can say many, processes involved in cooking or reactions that take place in cooking, they are all
Yeah.
endothermic. So I would write that reactions taking place in cooking in our daily life, they are all endothermic in nature. Reason being why?
Yeah.
Because you're trying to cook food, right? And if you're trying to cook food, you gotta take in energy, right? So it's gonna absorb energy. So that's how these reactions they proceed. And also a very famous biological process for the food making process for the plant especially, that is the photosynthesis, right?
Mhm.
So photosynthesis, you can see, is an endothermic reaction, right? So in this process, basically plants they convert the carbon dioxide and water to glucose, right? And they absorb this energy from the sun, basically, right? So that's how they are going to make the food for themselves. So in the endothermic reaction, if we talk about the surroundings, since they're absorbing energy from the surroundings and heat, so you can say that temperature of the surroundings, so the temperature of the surroundings is basically it decreases. Is that right?
Yeah.
Okay. So as a shortcut, you can just remember that the word exo actually means out because it is being derived from the term exit. Okay. And
Yeah.
the term endo actually means in, like kind of taking in something. Okay. So that's how
Yeah.
these two reactions are of separate kind, right?
Mhm.
So have you understood the concept of exothermic and endothermic reactions?
Kind of. Yeah.
All right. So you're clear with them?
Yeah.
All right. That's great.